the continuous flavor and the discrete flavor of math.
So what's the difference?
What is? Yeah, I was going to ask the same thing.
Vinny and we're on the same wavelength here.
Yeah. Well, I think that how I've come to kind of like understand some of the delineations of the different mathematical fields is there are like definitely tiers, and I think one of the highest, like, just to split it into two categories, is like discrete math and continuous math. And continuous math, I mean, quintessentially is going to be like your calculus based math. So yeah, calculus, real analysis, which is basically the theory behind calculus. And then discrete math are things like combinatorics, number theory, stuff that works with integers, whole numbers, rationals. You're dealing less with infinity in something like discrete math. Calculus is very like infinitesimal. And so is real analysis in those fields.
You mentioned tiers earlier. Is that in like complexity, or is that like different levels? Like you go from like calculus 1 to calculus 2. I know that's not going to be a different tier, but it's a different in difficulty along with like extra material and more concepts. Is it tiers as in like the math just becomes more difficult because you're having to do more transformations through equations? Or is it tiers in the sense of like it's the difference between calculus and linear algebra?
I would say that maybe tier was not quite the best word, but the way that I think about it is like you have your big like math umbrella, and you're trying to like divide it up into like what the different subsets are, and it's definitely not this simple, but because so many of them interact with each other. But if I were to then break that big like mathematics umbrella into two smaller categories, the first step would be continuous and discrete.
Okay.
Mainly speaking in a strictly pure math standpoint.
Which one are you studying?
I definitely fall into the discrete category for the majority of what I'm working on and what I tend to be interested in.
I'm curious how you actually study math at this point. Like, I feel like math is pretty well discovered. Like, what is your day-to-day in this job actually look like?
This is going to be one of my questions. It's like, we have a math. What more math is there?
So, yeah, that's the question that I get, like, kind of immediately every time when someone was like, okay, like, well, what are you doing this summer? And I'm researching math. And then it's always like, okay, what does math research actually look like? And for a while, I was just kind of like, well, I don't know. I haven't done it yet, so I'll figure it out. But what my day-to-day looks like right now is that I go to campus and I sit in a room with a chalkboard and I think and I draw pictures of shapes, and that's that's a lot of it. But in a more like general sense, that's not just like specifically what I'm doing right now. I think that the best way that I would describe what math research looks like is that there is quite a bit of like, there's always new math. I think that like what I've heard a lot from professors is that today's pure math is tomorrow's applied math. So like a field like topology is not particularly old. It's a relatively new field of math. But was initially studied out of a pure like curiosity standpoint, like something like the pure maths would be considered, but now is actually being used in things like mapping like protein structures in like biochemistry is the one that comes to mind. Topology is a hard field to describe, but it has a lot to do with like classifying shapes. And so the stuff that I'm doing right now is not at all related to that, but there are like plenty of questions that people don't know the answers to about certain things. And also,
Very
I mean,
descriptive.
I know that's quite vague. I think it's hard. It would be hard to get into without like using all of the vocabulary. Um, and I'm trying to speak a little bit more universally, but I think that like there a lot of the like math research and like the breakthroughs in math that happen now tend to be as like also um, things that bring like fields together in interesting ways that you wouldn't have expected, as opposed to like generating entirely new fields of math. A lot of the like Fields medalists, which is like the math equivalent of the Nobel Prize. These people have like written proofs or made connections between fields that use these like kind of disparate corners of math um, in interesting ways. And then there also is a component to math research that I think is what tends to feel more researchy, which is that um, it's a lot of like collecting data and finding patterns. Um, so when I am like sitting down and trying to figure something out, I don't go right into a proof. In fact, I haven't really done many formal proofs at all in my research yet. It's a lot of I'm generating a lot of data and trying to see like identify certain like mathematical structures that I'm familiar with. And that's kind of how math research or just math in general has worked for a while. Even like someone like Newton, who like, I don't know if you're familiar with like Newton's method, but it is a particular way to find the zeros of polynomials. And it's an iterative process. So it requires doing multiple calculations. And nowadays it's something very easy to do like on a spreadsheet that you can just generate a billion like data points in very quickly. But Newton was like doing all of those calculations by hand. So the research now looks similar in that it's still generating a bunch of data, but it can be done a lot quicker and you can do more complicated things.